Hello students, welcome to class 6 Science, chapter 12 Electricity and Circuits. We use electricity for many purposes to make our task easier. For example, we use electricity to operate pumps that lift water from the wells or from ground level up to rooftops. Electricity makes it possible to light our homes, roads, offices, markets, and factories even after sunset. This helps us to continue working at night. A power station provides us with electricity. However, the supply of electricity may fail or it may not be available at some places. In such situations, a torch is sometimes used for providing light. Electric cell. Electricity to the bulb in the torch is provided by an electric cell. Electric cells are used in alarm clocks, wristwatches, transistor radios, cameras, and many other devices. You might have noticed that it has a small metal cap on one side and a metal disc on the other side. The metal cap is a positive terminal of the electric cell. The metal disc is the negative terminal. All the cells have two terminals, a positive terminal and a negative terminal. An electric cell produces electricity from the chemicals stored inside it. When the chemicals in the electric cell are used up, the electric cell stops working. It may stop producing electricity. The electric cell then has to be replaced with a new one. Take a torch and look inside its bulb. Now remove the bulb and switch it on. Do you observe which part of the bulb is glowing? The thin wire that gives off light is called a filament of the bulb. The filament is fixed to two thicker wires. One of these thick wires is connected to a metal case at the base of the bulb. The other thick wire is connected to the metal tip at the center of the base. Inside a glass, an inert gas is also present, which helps the light to flow. A bulb connected to an electric cell. Let us try to make an electric bulb light up using an electric cell. Take an electric cell, a bulb, and a few wires and connect it as shown in the figure. Now try connecting A and B together. The electricity flows through the wire and the bulb starts glowing. An electric circuit. As you have seen earlier, we have formed an electric circuit in which the electricity flows from the battery to through the wire and reach the bulb. Sometimes an electric bulb does not glow even if it is connected to a cell. This may happen if the bulb is fused. Look at a fused bulb carefully. Is the filament inside intact? An electric bulb may fuse due to many reasons. One reason for the bulb to fuse is a break in its filament. Now do this activity. Take an electric cell, a bulb and a wire. Connect the wire to the center of the bulb and the other end to the negative terminal. Place the base of the bulb on the positive terminal. You see, the bulb starts to glow. Congrats, you have made an ohm torch. Electric switch. Take a switch which can be used to on and off the bulb. Now connect the battery, the bulb and the switches together with wire and try onning the switch. See, the bulb starts to glow. This is a circuit. You might have seen circuits in your houses which are used to light the bulbs. This is the same mechanism as you did before. Now, let's take a safety pin, 2 button pins and wire and make it as shown in the diagram. Now, connect the wires to a battery and a bulb. Now, try connecting the pin together on the other button pin and try connecting the wire to the bulb. You see, the bulb starts glowing. This is how an electric circuit works. Electric conductors and insulators. In all our activities, we have used metal wires to make a circuit. What if we use a cotton thread instead of a metal wire to make a circuit? Do you think the bulb will light up in such a circuit? The cotton thread cannot light a bulb, but a wire can. Why? Because wire is a conductor. What is a conductor? Conductor is something which allows electricity to pass through it. Do you now know why the bulb lighted? And the thread that we used is an insulator. Any material that does not allow electricity to pass through it is an insulator. Now look at a few examples of conductors and insulators. As we talked about electric cells in ancient India, now in the Prince Library of Ujjain in India, there is a well-preserved document called the Agastya Samhita, which dated back to the first millennium BC. It contains a detailed description not only of how to construct an electric battery or a cell, but also how to utilize the battery to split water into its constituent gases. Isn't it fun that our ancient Indians had so much knowledge